Right, good day and welcome. I'm Mr. Simons. This probability lesson, we're looking at three diagrams, but now dependent events. Remember three diagrams? Previous lesson I done independent, this one dependent. So they either asked independent, dependent, or sometimes a combination of both. But let's see what I mean with dependent events. Right, so if I use the example again, a bag contains 7 brown balls, 3 red balls, and 2 green balls. A ball is chosen at random from the bag and not replaced. So there we have 7 plus 3 plus 2. I have 12 balls in the bag, right? Every time I select one of these balls, it doesn't go back in the bag. So if I select one, then I'm left with 11. Select the second one, I'm left with 10. If I select the third one, I'm left with 9. So every time I select from the bag, my balls in the bag become less and less, right? So second ball there, it says then chosen and also not replaced. So every time I'm not replacing the items I'm selecting, it becomes a dependent event, meaning my probability is changing because my sample space is changing. So first questions there, or the questions asked, determine the probability that the two balls chosen, one is red and the other one blue. The probability that we can select green, then blue. The probability we can select red, green, or blue. Right, so let's go to the next slide. So drawing a tree diagram, I first need to understand my sample space. 7 brown, 3 red, plus 2 green. That gives me 10 plus 2 is 12 balls. Right, so 7 out of 12 is brown, 3 out of 12 red, and 2 out of green. 2 out of 12 is green. Right, so those are my probabilities that just go on my first branches. So first, drawing the tree diagram, I can select a brown ball, can select a red ball, or select a green ball. So I can select 7 out of 12 brown balls, I can select 3 out of 12 red balls, or I can select 2 out of 12 green balls. I hope you follow. Alright, after selecting a brown ball, I can again select brown, red, or green. But now remember, the balls are not placed back into the bag. So when I've selected brown, instead of having 12 balls as my sample space, I'm left with 11 balls. So the brown balls, remember I've already selected 1, so I add 7, I'm left with 6. So I'm left with 6 out of 11 balls. Remember the 1 wasn't placed back, so there's only 11 balls left in the bag. Red, I haven't selected as yet, so I still have 3 red balls left, but out of 11 balls because 1 brown ball is already out. Right? Then if I select green, green ball, I still have my 2 balls. I haven't changed or taken any green balls out. Right? But I've taken 1 brown out, so instead of having a sample space of 12, I have a sample space of 11. So 2 out of 11. Same thing applies after I've selected the red. I can again select black, not black, brown, red, or green. Right, so if I had 3 out of 12 red balls, right, I've selected 1, I'm left with 2 out of 11 red balls. The green ones I haven't selected, so there I still have 2 green balls, but out of 11. And brown I haven't selected, so I'm still left with 7, but out of the 11 balls because we have 1 red ball less. Same thing here, when I select green, I add 2. Now my green will become 1 if I select green again. I have 1 out of 11. The brown and the red I haven't selected, so I'm still left with 7 and 3. So there's 7 over 11, 3 over 11. My outcomes there, brown and brown, PB. Brown and red, PR. Brown and green, PG. Red and brown. Red and red. Red and green. Green and brown, green and red, and green, GG. No? Right, so let's answer the probability questions that were asked with it. So, determine the probability of the 2 balls chosen. One is red and the other one is brown. So, we first select one is red, the other one brown. So, I'm selecting probability red and brown. It should be probability of red times probability of brown, which is 3 over 12 times 7 over 11. Please note, if you forgot it's independent and it's not placed back, you're going to write 7 over 12 there. You're going to have 7 over 12, so this whole sum would be wrong. So very important with dependent events, You understand that the sample space decreases as we go along. So if we did a third row, it would be 10. If we did a fourth row, it would be 9, etc. Right? So probability red, then brown, 21 over 132. So 3 times 7 gives me 21. 12 times 11, 132. Right? Let's look at the next slide. Determine the probability that we would select green and then brown. So I'm going on this branch, green, and then from that branch I'm selecting brown. So GB. So probability it's green, 2 out of 12. Probability is brown, 7 out of 11. 2 times 7 gives me 14. 12 times 11, 132. So there my probability, 14 out of 132. Right, and if we go to the next slide, determine the probability, it's red, green, and then brown. So we're selecting 3 times. So that means if we use the product rule, probability of R times probability of G times probability of P. So R would be 3 over 12. I've selected one red ball, so I have one less. So for green, I haven't selected, so I have 2 over 11. I still have 2. Now if I select brown, I still have 7 brown balls, but remember I've taken 2 out of my sample space, so now I'm left with 10. So 3 times 7 gives me 21, times 2 gives me 42. 12 times 11, 132 times 10 gives me 1,320. Okay, I made an error there, but I'm sure that is correct. So that should read 42 over 1,320, right? So hope you follow, hope you understand. Wish you nothing but the best. God bless. Bye.